Hello grade 12s and welcome to this video. In this video, we are going to be working on the Mathematics Paper 2 for grade 12, May to June 2024. Okay, so as you can see with the watermarks on this paper, I got this paper from StanmorePhysics.com, and you can also use that website as a resource to download past exam papers. So this paper is for 150 marks and it is a total of 3 hours. Again, I will be releasing these in parts just because it's easier to render, okay, to export. It's just easier to export and upload like that. So these are the instructions that we have, and we move on to question 1. So we have question 1, and it says the number of pages in 10 A4 books and their corresponding weights in grams are given in the table below. The data is also represented in the scatter plot. Okay, so they already gave us a scatter plot. We don't have to plot things down. And of course, we have our X and our Y variables. So the first question says we need to determine the equation of the least squares regression line. So the equation of the least squares regression line looks like this. It is y is equal to a plus bx. So as you can see, it looks like the equation of a straight line, and the only things that we actually have to find is the value of a and the value of b. So in order to find those, all we're going to do is use this information that we have here. So on your calculator, this is what you're going to do. Okay, so on your calculator, you are just going to go ahead and press mode, and then you're going to choose the option that says stat. My calculator is a bit different, so mine number 3 says stat. So I'm going to go for stat. And then you're going to see that in option 2, you will have something that says a plus bx. That is your equation of your least squares regression line. We go for option 2. Then we have 2 columns. By the x, fill in your x values, and by the y, fill in your y values. Okay, and once you filled it in, you see that the number that we have over here is 10, showing us that we have exactly 10 numbers. Okay, so after filling that in, you can go over to the y-axis, okay, the y column, and you can go ahead and fill in the values that you have in your y values. Okay, and now these values are in. So there, you see that we also add at 10. So after putting the values in, to record this data, you're going to press, first of all, AC, then Shift, and then 1, okay? Then now, because we are looking for the equation of the least squares regression line, you're going to go for number 5, which says REG for regression. And as you can see that we have A and we have B. So to find the value of A, we say 1 is equal to, okay, so now that we know our A value is negative 43.72. So now we need to find our B value. So while on your calculator, you can just go ahead and press Shift and 1, and then again we'll go to number 5 for regression, and we want the b value, so we choose option 2 and say is equal to, and you see that b is 2.36 rounded off to 2 decimal places. So it means that the equation of your least squares regression line is y is equal to, our a value is negative, so that's negative 43.72, and then our b value is positive, so it's plus 2.36 x, and that is our answer. Okay, so moving on to the next question 1.2, which says draw the least squares regression line on the scatter plot in the answer book. So we have to draw that line on here. I'm going to just use this because I don't really have that answer book. So this is what we're going to use. Now, there's 2 main points that you usually need in order to draw the least squares regression line. Those points, first of all, is the y-intercept and your mean point. So that would be the mean of your x values and the mean of your y values. The y-intercept is simply just found by making x equal to 0. So if you look at the equation of your least squares regression line, if you made x equal to 0, that whole thing becomes 0. You'll see that you'll just be left with this, okay? Because it is the y-intercept. It's c in the equation of y equals mx plus c. Okay, so it's the only thing without an x. But the thing about this, and the reason I can't really take this, you have to also look at it within the context of what's been represented, okay? What are we actually looking at here? In this situation, the study is based on the number of pages, okay, in 10 A4 books and their corresponding weights. If we can see that this value, the y-intercept, which is a y value, if the y value is negative, the y values that we have here is the weights. We can't have a negative weight. And you also notice that they don't have any data for here. So it means we didn't have any books with pages like 20 pages and 40 and so on. So we can't really find that. So instead of using the y-intercept in this case, we're not going to use that. We'll just use the mean point. Also, when you're finding the y-intercept, you're making x equal to 0. The x are the number of pages. If you have no pages, then there are no books. Okay, so there's nothing two-way. So we're only going to use the mean point. Okay, so we're going to use the calculator to find the mean point. So that is just the mean of the x values and the mean of the y values. So to find the mean of the x values, we're just going to go ahead and go onto our calculator, and you can go ahead and just press Shift 1. But this time we're not going to go to regression. We're going to go to number 4, okay, and go to option 4. And now you see what we have, the information about the variables that we have. You see that number 2 here for my number 2, okay? That is the symbol for mean. That's the mean of the x values. So we'll say 2 is equal to, and you see that the mean of our x values is 120. Then we're going to do the same to find the mean of the y values. So let's find the mean of, let me just put it like that, y values. So I'm going to go ahead and say Shift 1 again to get this information. Go to number 4. And then I go and find that this is in option 5, the mean of the y values. And we get 239.5. Okay, so our mean point is 120 and 239.5. And that's what we're going to plot. So we'll go on a Cartesian plane, go to 120. I'll just put this in like a, standing out color. So 120 and then 239.5. So 120, then this is 200 here. And then we need to go to 239. Okay, so just try your best to find that point. Okay, so you'll notice that I put lines marking so that I'll remember exactly where each number is and I'll be able to properly measure. So that 239.5, you see that we have 250, or we can even start from 200. I noticed that this is actually counting in intervals of 10. So it's like 200, 210, 20, 30, 40, 50. So we're just going to 10, 20, 30, 40, and we're really just here, very close to this line, but just a little below. So we have 120 and just a little below it. Okay, so I might as well just put it on the line. But the important thing is that you label that point. So that is the 120 and the 239.5. Okay, that's the mean point that we have there. And then now to draw it, I know it looks so weird and it's kind of like, how do I actually draw this now since I don't even have that y-intercept? Well, you can still draw it, but it's just going to be a little different. So with reference to what that y-intercept would have looked like, since it would have been 0 and negative 43.72, I'm just going to see that it would have been, since the x value is 0, right, has an x value of 0, and then a y value of negative 43.72. That would have been somewhere like, see, this is 50, so it would have somewhere like down here. It would have been somewhere there, right? It would have looked something like this. So your goal is really, in a situation where you have your y-intercept, your goal would be to connect the mean point and the y-intercept, okay? Don't worry too much about trying your best to join the lines. That's not really what we're doing, because the line of best fit is a line that is really joined by the y-intercept and then the mean points. Then you'll notice that the points may be close to that line of best fit or far away from it, depending on the correlation that you have. So if it has a strong correlation, you will notice that the points are closer to it. And if it has a weaker one, the points will be further away from it. Okay, so what I'm going to do is I'm really just going to erase these because I don't really need that. That's not there in the situation. Okay, so because I know I don't have any data here, I'm just going to really do that. And so that's my line of best fit. So even if a new point had to come in, I'll be able to see whether this point is closer to the line or further away from the line, and you'll be able to spot things like outliers as well. Okay, so that is the answer to that, and we finally move on to the next question. 1.3 says, predict the weight of an A4 book that has 110 pages. Okay, so let's think about it like this. We're going to predict, well, we already have the line of best fit. We can use that to make predictions, okay? Remember, it's not going to give you an accurate answer. The reason why is because this is sort of like a real life experiment going on. Someone is taking books and measuring the amount of pages they have, and then weighing it and seeing how that corresponds. Okay, so even the answer we get in the line of best fit and the answer that you get in the equation, they're both still predictions. So I'm going to use the equation of the line of best fit, and all you have to do here is, because they asked for you to predict the weight, okay, of an A4 book that has 110 pages, do you see that in your data, your pages are your X values? So it means they've given you an X value and you need to substitute it into your equation to get a corresponding Y value. So go ahead and just say Y is equal to negative 43.72 plus 2.36, and then in place of X, say 110. So when we substitute this, we get 215.88. Now remember, the Y value is speaking about the weights, which of course can have decimals. So I'm going to leave it like that, 215.88, and this is measured in grams. So this is the amount of grams approximately that amount of pages will have. Okay, moving on to the next question. The next question, 1.4, says, calculate the percentage weight increase. Okay, percentage weight increase between a book with 110 pages and a book with 130 pages. Okay, so this is really just calculating percentage increase. So this is the calculation for percentage increase. You're going to take the new amount that you got, right? And you're going to subtract it by the original amount. And you're going to divide that by the original amount. And it's really because we're just trying to compare the difference to the original amount. You're just seeing how different is it compared to what it used to be. So the new amounts that we would have is because they said a book with 110 pages with a book with 130 pages. So we'd have to take the one with 130 pages minus the one with 110 pages divided by the one with that. But remember, it's saying calculate the percentage of the weight increase. This is just the pages. Okay, so we know the approximate amount of grams, the weight of the 110 pages. So it means that first you have to find the weight of 130 pages. Now let's just check if we actually do have that information in our table. Do we? No, we only have 135, okay? 135 pages will give you 250 grams. So we don't have that. We can as well just go ahead and find it. So you can use your calculator to do this. And you can just, in place of 110, let's just go ahead and substitute. So we're going to substitute 130 to find that. Okay, so is equal to, and we get 263.08. Okay, so those are the results. That is the weight. So let's take, first of all, the new weights that we have, which would be this 263.08. And then, and I notice now I didn't include a specific thing. This is just to find, well, this will not be the percentage yet. So you'd have to multiply to make it a percentage by 100. Okay, so that part. Okay, so we're saying 263.08 minus the original weights that we had, which was this one, okay, for the 110 pages. So that's 215.88, and then divided by the original, which is 215.88. Then just multiply that by 100 and it will give you the percentage increase. And there is my calculation. Okay, I put it back on comp. So to do that, you just press mode and then 1. Okay, so I put it back here just so that we can calculate. We don't even need the data anymore. This is the last question for this data. So that is equal to, so that is 21 points rounded off to 2 decimals, 86%. That is the percentage increase that we have there. Okay, so that is the last question that we have for question 1. And then we finally move on to question 2. Question 2 says 50 athletes need to access suitable training facilities. The table below shows the distance in kilometers that they need to travel to obtain access to suitable training facilities. Okay, so people are training and they're just showing the kilometers that they need to travel to reach these training facilities. So we have the first question says complete the cumulative frequency column provided in the table in the answer book. I don't have an answer book. I did manage to find graph paper though for the next question. So we'll work with that. With the cumulative frequency, what I'm going to do is I'll just write it here. Okay, so this is my cumulative frequency. Just leave it like that. So let's go ahead and fill that in. Okay, so this is our cumulative frequency column. And in order to fill this in, you're first of all just going to drag the first number over, and that is 3. And to get the next number, you say 3 plus the 7, and you get 10. And then 10 plus 20, and that's 30. 30 plus 12, and that's 42. 42 plus 5, and that's 47. And then 47 plus 3, and that is 50. So there we go. And that's how you fill in your cumulative frequency. Okay, next question, 2.2. Okay, 2.2 says, on the grid provided in the answer book, draw a cumulative frequency graph, which is an ogive, to represent the above data. Okay, so let's just get that graph paper. Okay, so this is our ogive that we're going to just draw. Here's our graph paper. So with the information that we have, please note that we're only going to be using this information, and that's your X values and the cumulative frequency, because this is a cumulative frequency graph. First and foremost, the number that you see here, and I've mentioned this before in my other videos as well, the number that you see here, right, that X value, the Y value that is going to go with it must always be 0. So even if it was a 5 here, right, the X value will be 5 and the Y value will be 0. But in this case, it's 0. So the first points that we're going to have would be this X value of 0 and our corresponding Y value of 0 as well. So that's 0 and 0, and that will just go right there. Okay, we're done with that one. Then the next one, it's going to be the 5 and your cumulative frequency value of 3. See? So now it's just going to be the 5 with the 3, the 10 with the 10, the 15 with the 30, and so on. So we have 5 and 3. So that's 5 and 3. Then we have 10 and 10. So that's 10 and 10. And then we have 15 and 30. So that is the 15, and our 30 is over here, 30. And then 20 and 42. So that's 20 and 42. So here is 40. And then you just go, since this is intervals of 5, as we can see, so 41, 42. So 20 and 42 would be there. And then the second last one is 25 and 47. Okay, so that's 25. This is 42. So this is 45 here that we have. And then 47 is just 46, 47. So 25 and 47. And then lastly, it is 30 and 50. So that is 30, and then 50 is right over here. So we could just go 50 and then find 30. So there. Okay, so there we go. 30 and 50 is our last value. Then we're just going to join these points, and it's really just going to create a curve. So I'll just use another bright color. So let's use blue. You're going to just draw it, and it's going to be a curve like that and down on there. Okay, so there we go. There's our ogive, and we can go ahead and move on to the next question. Question 2.3 says, calculate the interquartile range of the above data. So the IQR, okay, when you're finding the interquartile range, do you notice that the word range is in this? Normally, to find the range, just the range of a data set, you take the highest, the maximum minus the minimum. So with the interquartile range, it's also a range, but it's a range of your quartiles. You know that you have a Q1, a Q2, and Q3. So the IQR, to find that, would be your highest quartile minus your lowest quartile. That is Q3 minus Q1. So that's what we have to find in order to be able to find the interquartile range. So how do we find Q1 and Q3? Well, with an ogive, that kind of information, it's much easier to find. And again, I'm just going to explain it because I want this to also just be a learning opportunity as well. So you can see your quartiles like it is a block split into 4 parts, right? If you're looking for the first quartile, right, like that number that's going to be there, that's going to mark the first quartile, what you're going to do is you can see that out of these 4 blocks, this is 1 out of the 4 parts. So in order to find that quartile, you're going to go ahead and say your total frequency, so it's like total frequency multiplied by that, so 1 out of the 4 parts, that would give you your Q1. Well, specifically the position of your Q1. Okay, so remember we're saying total frequency times that. The total frequency that we had was 50 because that was the highest. When you added everything up together, you saw how we added that. If you add everything, it will give you 50. So because of that, we're going to just say 50 multiplied by a quarter, okay, which is like 12.5, right? So 12.5. So now what do we do with this number? Remember I said that that's actually the position of the first quartile. We're taking this and we're multiplying it by that frequency, right? That'll just give you the position of it. To find out the exact value of Q1, you're going to take this number 12.5. Remember, this is a frequency value. So you're going to take 12.5 on the cumulative frequency column. And when we find that, so that's around about here, we're going to say this is 10, 11, 12.5 is here. And you're going to use your ruler and draw a line, a straight line to your ogive. And once it hits that spot there, you're going to go down. Okay, so we're going to go down like that. And you see that that number is about 10.5 because this is also in intervals of 1. So 10, 11, 12, 13, 14, 15. So that is 10.5. So when we answer them, we'll say Q1 is equal to 10.5 kilometers. Then we need to find Q3. So to find Q3, again, the third quartile, think about it as a fraction. It would be how much as a fraction of your data. So it's the third quartile. So this would be 3/4, okay, 3/4 of your data. So that, to find that, you're going to say Q3 is equal to your total frequency, and you're going to multiply this by 3/4. Okay, so that is the 50 times 3/4, and that's going to give us like, that's 25 plus 12.5, which is 37.5. So again, this is just the position of your Q3. That's just the position of it. So to find it, you're going to go on your ogive and you're going to look for 37.5. So 35 is here, 37 is 36, 37.5 is in the middle. Then I'm going to draw that line right to the ogive. And once I hit the ogive, so that's not a very straight line. It just needs to be, try to make it as accurate as possible just to help you. But don't worry, they have a range of answers that they will accept. And then if it goes beyond that, then they can't really, accept it. So somewhere around there, once you hit the ogive with your ruler, of course, you're going to go down. And then you see that it's here. It's about, we have 15, 16, 17.5. So I know that it's in between. So that's why I'm saying 17.5. So it means that Q3 is 17.5. So again, to find the IQR, remember how we find that? We say Q3 minus Q1. So that's going to be 17.5 minus our 10.5 kilometers, 10.5. And then, of course, the 0.5s cancel. 17 minus 10 is 7. So our IQR is 7 kilometers. Okay, so that's our answer. Please do let me know in the comments if there's like mistakes that I made here and there. Okay, because remember the memo isn't really out. So I don't really have something to like confirm whether, that was correct or not. Okay, so that's the answer that we get there. Then we move on to the next question. Okay, we're on 2.4 and 2.4 says, the families of 4 of the athletes above who stayed between 15 to 20 kilometers from a suitable training facility. okay, decide to move 10 kilometers closer to the facility, in which interval would the number of athletes increase? So the families of the 4 athletes who stay between 15 to 20 kilometers. So it's one of the people here. And I'm just going to actually pull this data down. I think it will just be easier to work with. Okay, so the families of people staying here between 15 to 20 kilometers. So that's this, right? So you see that there are 12 athletes here. So they're saying 4 of these athletes, what happened is that they moved 10 kilometers closer to the facility, okay? And they want to just know in which interval would the number of athletes increase. So let's actually just put down a picture of what's going on here. What's going on here is that the people who used to be here, 4 of them, only 4, they are going to move 10 kilometers closer. So let's just see it like this. The people who were within 15 to 20, which is this, right? Let's just put a line for the travel distance. So they moved 10 kilometers closer to that training facility. I'm just going to put that, say train, okay? Training facility. This looks like a prison, but okay. So we have a training facility and we're moving 10 kilometers closer. So you can think about it like this. If you're closer, the distance between where they now live and the training facility is now going to be shorter, okay? So 15, they used to be 15 kilometers away. Now they're going to be, if they're 10 kilometers closer, it means they will be 5 kilometers away. Then I'm saying 2, if they used to be 20 kilometers away and they move 10 kilometers closer, they would now be 10. Okay, so you can see where they end up. They end up where x is greater than 5 but less than 10. So that means that they will move from here to this class, because that would be the class that is between 5 to 10 kilometers. So it moves to there. Okay, so what happens with the people then? It means that the people, the 4 athletes, right, who are moving from this place, they are coming out of this class. So we will have 4 athletes leave here minus 4, and 4 athletes would go here. Okay, so at least now we know the class. That's actually what they asked for. They asked in which interval will the number of athletes increase, and that would be this interval over here, which is x is greater than or equal to 5, but less than 10. Okay, so that is the answer for that question. Moving on to the last question in question 2. So 2.5 says calculate the estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer to the facility. Clearly show all working. So they're really just asking us to calculate the estimated mean, but this is after those 4 families have moved. Okay, so looking at that, you see that I've already put the calculations that is going to happen here. So we know now that this value, the number of athletes here would change. It's 12 minus 4, which is 8. And here, this value would change to 11. So that's really all we have to do. And if you had to calculate the mean distance, even without this change, it will still be the same because it's the mean, okay? We just took out from here and put here. So nothing new got added. Okay, so this is what we need to calculate the mean. So the first thing we're going to need to calculate the estimated mean, okay? It is estimated because we're using group data and not specific numbers, okay? So the first thing we're going to need is the midpoint. And so this is really where the estimation comes from. So the reason it's actually called an estimated mean is specifically because of this. We're not going to each of these 3 athletes, for example, and asking them, how far do you live from a training facility? And then go to another one and ask, okay, how far do you live from a training facility? Because if we did that, we would get different values. But all those values would range between 0 to 5 kilometers. So instead of finding each of them, which we can't actually right now, instead of doing that, what we do is get an estimate of 0 to 5 kilometers. And we do that by finding the midpoint. So we say 0, that's 5 divided by 2. And that would be an estimate of it, okay? So it's just the midpoint of it, or an average. So that would be 2.5. And then we'll do the same thing here. 5 plus 10 divided by 2. So that's 15 over 2, which is 7.5. And so on to get the remaining midpoints of everything. And these are the values that we get. Then, in order to continue with this to find the estimated mean, there's another thing we need to do. You see, yes, we found the midpoint of these values, but remember that in this category, right, there are 3 athletes here. So the total kilometers that we would have would not just be 2.5. It would be 3 of these athletes 2.5 kilometers, okay? So we're just really giving all of them in this category 2.5 kilometers. We're estimating that that's how far they are from that training facility. So in order to get to this part, we're just going to say that midpoint multiplied by our frequency. Okay, so we're going to say 2.5 times 3, the number of athletes that we have, and 7.5 times the number that we have here, which is now 11, and so on. And these are the values that we get. Okay, so we get all of those. Then now to actually find the estimated mean, because that's actually what we're looking for. We're looking specifically for the estimated mean. To find this, what we're going to do is, the way the mean is normally found is you take all the values, okay, that you have, the data points that you have, and then you divide by the number of data points. So the data points that we actually have here would be these. You see, because instead of just taking 2.5 kilometers, we know there are 3 athletes in this category. So the total kilometers we have is 7.5. So to get those values that we're going to add, we're going to take these values, right, and add them up together. So we're going to add all of these up together. And when we add them up, we're going to divide by the number of athletes that we have. So that will be the number of people that participated. And the total athletes we will find by, of course, summing this up. But the things, we already have that in the cumulative frequency. So that would be this value that we have here. The last value, which is 50. So everything adds up to 50. So whatever we get here, we divide by 50. And when we add that up, we get 675. Okay, so we're really just going to say our 675 divided by 50 to find our mean. And our mean is 13.5 kilometers. So that is our answer for the estimated mean. And that is it for question 2, which is a total of 11 marks. And then we finally move on to question 3, which is on analytical geometry, and that will be in a separate video.